All right, here we are for a new set of problems, stoichiometry and molarity. So remember that in almost all of these cases, we're going to be moving from the real world units to mole units. And in order to do that in these problems, because it deals with molarity, we're going to be taking advantage of the equation that molarity is equal to the moles per the liter. So just a quick reminder that on all of these problems, molarity is equal to moles per liter. That you can plug and chug and get any one of a number of things. You can get molarity, you can get moles, you can get liters, you can get anything that you want out of that. All right, so in all cases, you've got the real world unit, and then you've got the moles, which is the chemistry unit. So what does it want? It wants milliliters here, and they gave you that it was 0.5 molarity here for this. So this guy here is 0.5 molarity. And they gave you in the real world that this is 5 grams of this. So again, you've got grams over here on the right, you got milliliters. You can't just go over here and say, well, that's 2/3 over there. It doesn't work that way. So the first thing that you have to do is get from the real world unit to our mole unit down here. That's a gram unit, so you have to divide by its molar mass. And if you add up the molar mass of potassium sulfide, you get 110.3 grams per mole, assuming my math is correct. At that point, you're going to have 0.0453 moles, if I've done my math right. And again, please keep in mind that we're not taking these two things here into account until we do the mole ratio, which we're going to do now. We're going to start at a 3 and we're going to go over to a 2, so we got to get smaller. Always multiply by where you're going and divide by where you came from, so we're going to multiply that guy by 2/3. That's there, and then when you do that, you end up with 0.0302 moles that are here. And now we want to get from moles up to this guy up here. What do I know? Well, I know that I have the moles, so I have this, and I know that I have the molarity, which is this. So if I take and I want my liters, then I'm going to have to divide the moles by the molarity in order to get the liters. So I end up doing my math on that, and I end up with an answer of 0.0604 liters, except that it wants milliliters. So fine, multiply it by 1,000, 1, 2, 3, and you should end up with 60.4 milliliters as your answer there. Because remember that there are 1,000 milliliters in a liter.